This is the brief on injection molding defects. You know, injection molding creates the everyday plastic stuff we use, but getting it right takes a flawless balance of physics. Otherwise, we end up with weak, deformed parts. So manufacturing fails usually come down to three interconnected things: temperature, pressure, and mold design. First, we've got the temperature trap. It's honestly just like baking a cake. If your oven's too hot, the edges burn, right? But cool it down way too fast and the center just collapses. With plastics, uneven cooling makes parts shrink and twist into what we call warpage. Conversely, injecting plastic too fast traps and superheats the air, causing literal burn marks. It's all about gradual cooling. Second, there's the pressure problem. See, temperature dictates flow, but pressure dictates if that flow actually fills the space. Not enough pressure? You get voids, weak air bubbles inside thick parts, or short shots, where the mold literally doesn't fill up. Now you might be wondering, why not just crank up the pressure? Well, not if that pressure forces the mold open and leaks plastic everywhere. That's a messy defect called flash. Finally, we reach the design dilemma. Even with perfect temp and pressure, the whole shebang fails if the physical mold fights the plastic's physics. Variable wall thickness is a massive culprit. Thicker parts shrink differently, pulling material inward to create ugly depressions called sink marks, or just warping the part completely. The ultimate fix is redesigning the mold for uniform wall thickness and symmetry. Ultimately, perfect injection molding comes down to harmonizing temperature, balancing pressure, and designing uniform walls to keep your plastics in perfect shape.